Good afternoon. Hey, what's going on? We got the whole team there in Hopi today, huh?
Jada's not here, but everyone else is. I'm just kidding.
Where is Jada? You guys come for a little calculus today? Awesome. All right, so we'll see how that goes. All right, well, dang, I needed to talk to Jada before we got started. Anyway, all right, well, so Tobias, I didn't forget about, I still have to unlock some of your stuff, so I haven't forgotten. I just haven't done it yet. I'm just swamped. So, but I'll try to get on that first thing tomorrow. Okay. So you look for that. Also, Weston, I'm almost done with your letter. Unfortunately, I've been writing like other letters this week, but yeah, yours is. I would say I just need to polish it. It's pretty much written, so I just need to spend another probably 10 or 15 minutes. And so my goal is that probably Friday morning to send it out to you, probably before noon. So if you want to look over that, and then if there's any tweaks or anything that you want on that, that's not going to hurt my feelings if you say, I'd really like you to talk up a little bit about, my career objectives, or, whatever you want. What it just, as you read it, if there's something that you want me to emphasize more, but look for that Friday, and then if we need to tweak it, then that might be into next week. But anyway, that's kind of my time on that. So okay. So do you guys have any questions, comments, anything before we get started here today?
Is the midterm going to be okay? So there's like next week, which is spring break. Is the midterm going to be on Monday and Tuesday of the next week, or Wednesday and Thursday?
No, Wednesday and Thursday. Now, Monday and Tuesday, you're actually going to have a substitute. Dr. Blake is going to be he's going to be the substitute, and he is going to cover some new material in Chapter 9 that is not on the midterm. Also, if you have questions that I'm going to talk to him about, if you have questions of material from Chapter 7 and 8, like let's say you've been working problems or whatever, then I think it'd be okay for you to just ask those, okay, as well. And so you'll take up as much time as you want, but now I'm going to do all the midterms for both trig and calculus on Wednesday, Thursday, okay? And so it'll be like before. I guess I need to send out emails, but it'll be like before, where it's open book, open note. You'll take part 1 on Wednesday, part 2 on Thursday, and then your overall grade will be the average of the two, okay? All right. Anything else?
Are you going to watch Captain Marvel this weekend?
I'm hoping to. I actually, my first 5 plans for spring break have all fallen through. I mean, we talked about. I mean, at one moment, I think I mentioned we were talking about going to Hawaii or a cruise or just something crazy fun. But then Prescott even fell through, or, Vegas. And anyway, but we might get a 2-day weekend in Phoenix, and I would love to see it like in an IMAX or something down there. But if that doesn't work, I've got a buddy that we're going to drive over to Flag on Saturday. So that's my backup to plan G if that doesn't work. So anyway, are you planning on seeing it?
Yeah, definitely.
Awesome. So where will you see it? Down in Lakeside or?
Well, I think I might be going to the Valley this weekend. So if I do, I'm going to try to go to somewhere down there, probably with my cousins.
Awesome. And how about you, Weston? Do you have any big plans for the spring break? You gonna go see Captain Marvel?
I don't know if I'll go see it. Probably will, but not any big plans.
Not any big plans. Well, I hope we all get to have some kind of fun this coming week. So anyway, we'll see what happens. Well, let's. I'm actually excited to teach this lesson here today because this is the last section of chapter 8, and so this is the last bit of new material that that on the midterm. So I'm because I would feel bad if I had the sub teach some new material. Although I do fine, but so whatever we do tomorrow, and then whatever we do, with the sub on Monday and Tuesday after spring break, that new material will not be on the midterm. So this is it, and this is improper integrals. Now it's a little abstract, and as I begin to teach it, I know that it is abstract. But when you actually start doing the problems, it's actually not that bad, and it leads us to future stuff that we're going to be doing in chapter 10. So I like that. All right. So improper integrals. So proper integrals have two properties. Why is this anyway? Okay. Number one, the domain is finite. Number two, the range is finite. So if one of those things doesn't happen, then it's not a proper integral, and we call it an improper integral. So this is like a type 1 improper integral where the domain, see, the x's go on forever. So if you're trying to figure out the area under the curve and this goes on forever, well, that's improper because the domain is not finite. Type 2 is where, see, the range, the y values go on up forever. Okay? So the two different types of improper integrals. So the question is if you have like the area under a curve, let's say you want to find the area from 0 to infinity, is it possible that if the x values go on to infinity, would the area under that curve have to be infinity, or could it be a number? What do you think? We want the area under this curve, and this part goes to infinity. The x value goes to infinity.
I think it could be a number.
Okay. What about you, Tobias? What do you think?
I don't know. I feel like it would be infinity.
Okay. I get both of it. I think I leaned more toward infinity. When I was a student, that's kind of how I would have thought, because the idea, well, it's going on forever. But see, here's the thing, is that when you think about our ideas of limits, say if we use the idea of a limit and we're sort of limiting, taking the limit of this area, we can actually calculate it. And so this is what the idea is of doing an improper integral is, see, it's like we're doing the integral from 0 to infinity of the function. All right, now, anytime you have an infinity as one of your limits of integration, that's improper. That's an improper integral. Your calculator can't do it. But Weston, that doesn't mean that we can't work it out and that we can't get a number. Okay? We just have to do it with limits. Okay? All right, so basically this is what we do. Is we take the limit, if one of our limits of integration is infinity, then what we do is we replace it. If it's the bottom limit, if it's going to negative infinity, we replace it with a, and the top limit is b, just from a to b. So we replace the infinity with b up here, and then take the limit as b approaches infinity. Now you might say, well, how is that any different? Well, subtly it is different because now the limit of integration is not infinity, it's just approaching infinity. And so then that makes this a proper integral. See, I know it doesn't seem like that's a big deal, but that's the big step today. I mean, that's the big cheese, the big story to tell today is to say if you have a limit of integration that's infinity or negative infinity, replace it with a limit. And then you can do it. Okay? Now, you can do it, but your calculator, just so you know, your calculators can't do these. They can't do improper integrals. So you just have to know how to do it. All right? So just sort of ignore all of this, and then you do the antiderivative. Okay, so the antiderivative of e to the x is e to the x, or e to the u divided by the derivative of the u. So the integral of e to the negative x over 2 is e to the negative x over 2 divided by negative 1/2. Okay? Now, dividing by negative 1/2, that's the same as multiplying by negative 2. Okay? So, we've got the antiderivative. We still have this limit out here. Okay? All right, now we plug in the b and we plug in the 0. So, when we plug in the b, we get negative 2 e to the b over 2 minus negative 2 e to the 0 over 2. All right, and now is where we think about this limit. Because if we think about this as a limit as b approaches infinity, well, infinity divided by 2 is still infinity. E to the infinity is infinity, but you have a constant over infinity. And so the constant over infinity is going to go to 0. And then you have minus a negative, and then e to the 0 power is 1, so plus 2. So you end up with 0 plus 2, so your answer is 2. So, Weston, you were right, that it turns out that this area, even though you're going to infinity, that area is exactly 2. Now, there's a part of me that, I've been teaching calculus for years. And there's a part of me that is still kind of amazed that we can get an area of an infinite, we have an infinite area there, but the limit goes to infinity, but yet the area is a specific number, like 2. Okay. All right. So let's see. So suppose that so in practice 1, let's start you off at, if we wanted to take the integral from 1 to infinity of ln of x over x dx. All right. So you can't have an infinity there. So I actually put it in as the limit. So it would be the limit as b approaches infinity of the integral from 1 to b of ln of x over x dx. Okay, so see if you can do that one. All right, so Weston, do you have this one?
The x in the denominator is throwing me off a little bit. Can you help me with that real quick?
Sure.
Like,
Okay, so do this with a u substitution. Let u be ln of x, and then the derivative of ln of x is 1 over x.
okay, yeah.
Okay? So u substitution, let u be ln of x.
Okay, I got infinity, but I don't think that's right.
All right, well, let's see. Okay, so when we substitute in, we're going to get the integral of u du. So then the integral of u du would be u squared over 2. And then we substitute that back. So that would be let's see here. Let me okay. So that would be the natural log of x squared over 2 and from 1 to b. Okay. I'm going to throw in an extra. Yeah, so it looks like we do get infinity. Here, let me throw in a couple of extra steps here. All right, so we get natural log of x squared over 2. So then when we plug in the b and the 1, then we have the natural log as b approaches infinity of the natural log of b squared over 2 minus the natural log of 1 squared over 2. Okay, now let's get rid of that. All right, so then now we plug in infinity. So as we plug in infinity, the natural log of infinity, see, here's the natural log graph. It goes up slow. That must be the original graph. The natural log graph, it rises slowly, but it still rises. So the natural log of infinity is still infinity. Infinity squared is infinity. Infinity divided by 2 is infinity. So all of that gets us infinity. All right, and then the natural log of 1 is 0. So 0 squared over 2, that's 0. And so then my answer here is going to be infinity. Okay? So you're right. Now, so what that means is not always are we going to get a number. Okay? Now, if we do get a number, we say that the integral converges. Okay? And if we get infinity or negative infinity, then we say that it diverges. Now, that's going to be a really important idea in chapter 10, because in chapter 10, almost all of what we do will be looking at integrals and series and determining if the series diverges or converges. Okay, so this will be even more important later. Okay. All right, let's see next. Okay, so the type 1 integrals. All right, now I don't know if these actual integrals really help you. They might if you want to write them down. To me, what really helps is the stuff to understand the difference in the type 1 integrals is the stuff that's in that I've highlighted as well as the little drawing. At least that helps me. These are the different improper integrals of type 1. All right, 1, f of x is continuous from a to infinity. So the interval goes from a all the way to infinity. So that's why, because the x value goes to infinity, that's what makes it improper. All right, the second one is it's continuous from negative infinity to b. So the fact that this end goes to infinity, that's what makes this one a type 1 improper integral. And then the third one is if it goes to infinity on both sides. So it's continuous from negative infinity to infinity. So it's both ends that make that an improper integral. All right. Now, sometimes when you go to evaluate these, okay, kind of what the book would have you do is break this up into 2 integrals. Let's see, no, that's something like that. See, what the book would have you do is to break this up into 2 integrals. And so to integrate it from negative infinity to 0, and then 0 to infinity. Okay? But what I like to do is if you look at the graph and you see that this is symmetric, then all you have to do is do 1 improper integral and then double the area. Okay? That's way easier. So that's kind of the way that I like to do these. So let's go to this one. Okay? Now, so if one of the things that will help here is to look at the graph. Okay? So for practice 2, this is also symmetrical. So instead of making this 2 separate integrals, just integrate from 0 to infinity and then double your answer. Okay? All right? So let's see if you can do that one. All right, so Tobias, do you remember what the integral of 1 over a squared plus u squared is?
No, not from memory.
Okay, so what you would want to do if you didn't remember that is you'd want to, that's probably one you'd want to look up. And so like those tables of integrals, or back at the beginning of chapter 8 where it had that list of 20, you'd want to see if you could find that. Okay, so Weston, do you remember that 1 over a squared plus u squared? Do you remember what that integrates to?
I feel like I almost know what it is, but I can't place it.
Okay, what it is it's the inverse tangent of a over u. Okay, so what you do is you say, well, first of all, okay, I'm getting the cart before the horse here. Okay, the first thing you have to do is change it from an improper integral with the infinity to a proper integral. So put the limit as b approaches infinity and then put the b there. Okay? Now, when you do the integral, see, this is the formula that I'm using. The integral of dx over a squared plus u squared is 1 over a inverse tangent of u over a. And so here, what I'm going to do is let a be 2, and then u is x. And then I want to pull that 3 out in front. Okay, so I pull the 3 out front, and so the 3 in front of the multiplied by the 2, that's where the 6 comes from. And then now you say, all right, now when I integrate this, this is going to be 1/2 inverse tangent of x over 2. All right, so everybody okay with that? All right, now the 1/2 I can also pull in front with the 6, changing it back to a 3. And so now I'm going to do the inverse tangent of b minus the inverse tangent of 0. Okay, so now I'm going to do the limit. So as b approaches infinity, what's the inverse tangent of infinity? Here's the graph of the inverse tangent. Remember, of all of the inverse trig functions, this was the only one that I said you needed to remember. So as x goes to infinity, what does the y value of the inverse tangent graph approach?
Pi halves.
Pi halves. So pi halves. So the inverse tangent of infinity is pi halves. The inverse tangent of 0, well, as x approaches 0, the y approaches 0 as it goes through the origin. And so what we have then is 3 times pi halves minus 0, or 3 pi halves. All right. All right, questions on that? So when you're doing this, you probably want to write that down, sketch that graph, as well as the formula that you need, okay, when you're doing these. Okay. So this is kind of a bigger graph of the inverse tangent. So it goes through the origin, and then as the x increases, the y gets closer to pi halves. As x approaches infinity, as x approaches negative infinity, the y value approaches negative pi halves. Okay, now, so in chapter 10, part of our the big idea of chapter 10 is going to be what we call convergence and divergence. So this example has a little bit of that in it. And so it says the improper integral from 1 to infinity of dx over x to the p converges if p is greater than 0 and diverges if p is less than or equal to 1. So remember, converges means that we get an answer, a number. Diverges means it goes to infinity or negative infinity. So in chapter 10, we learn a lot of little tricks like this to say if it's x to some power, then you look at the power, and if the power is greater than 1, it will diverge. Okay? So let's look at the example or practice problem. So does this one converge or diverge based on what you just wrote down?
Would it converge?
Well, so the p is 2. So if p is equal to 2, that means it's greater than 1. And so that means it converges. So if the exponent, if it's x to the squared, x to the third, x to the fourth, x to anything where this p here is greater than 1, it will converge. Now, we don't have to, in this problem, we don't have to know the sum. And see, that is kind of the nice thing about chapter 10, is a lot of times we don't have to calculate the integrals, or we don't have to figure out what the sum is. We just need to know, does it converge or diverge? And if we know this fact here, it's going to converge. And then that's it. We're done with that problem. All right. Let's do at least one of the type 2 integrals, improper integrals. So once again, I would suggest you write down the parts that I've highlighted as well as maybe the little graphs here. Okay, so these are the type 2 improper integrals. They're type 2 because it's the range, the y value that goes on forever. So here, f of x is continuous, not at A. So it's at A, that point A, where the graph goes up to infinity. So it's the left endpoint of the interval. All right, for part B, or number 2, it's where B is discontinuous. So it's the right end of the interval that goes up to infinity. And then the last one, it's like where you have a vertical asymptote in the middle of your interval, and so it goes to infinity on both sides of the vertical asymptote. So it's continuous everywhere else except at that one point. It goes on up forever. And then this last little part that I've highlighted is really what we've been saying all along. If the limit is finite, so if we get a number, then we say the integral converges, and that the limit is the value of the improper integral. So it can have an answer like 2 or 5 or 7, and it converges. If the limit does not exist, then the interval diverges. So if it goes to infinity or negative infinity or doesn't exist, then we say that it diverges. The integral diverges. Okay. All right. So what do you think about this? Does this converge or diverge?
Diverge.
Okay. Why do you think that?
Because, well, there's not a power in the bottom, so it probably means to the first power. And if it's equal to 1,
Okay. Okay. Here's the thing, though, is that where you have like x to the p, that having the 5 here, 5 minus, then that makes it so that formula doesn't work. It just has to be x to the p. But I still like your reasoning. Okay. See, if we actually go through it, if we do see the integral of dx over 5 minus x is going to be a natural log, because the derivative, whenever you see the derivative of the bottom is the top. Well, except for a negative, and we just put a negative out front. Okay. So then when we evaluate this, are we going to get a number or not? Well, what do you think?
Yeah, we'll get a number.
We'll get a number. See, we're going to get negative natural log of 5 minus 1 minus negative natural log of 5 minus 0. All right, so then that gives us the negative natural log of the absolute value of 4 minus a negative plus the natural log of 5, absolute value of 5. Now, since both of these are positive, we can drop the absolute value. And then I'm going to just reorder it. Natural log of 5 minus the natural log of 4, that's the natural log of 5/4. So that's a number. That's a number. So if we get a number, then the answer is what?
Converge.
Converges. Okay? And it doesn't matter what the number is. Okay? And so that makes it kind of nice here. Oops. Okay. So I had a student in one of my previous classes that said, well, so what would one look like that diverges? Well, and so I just made one up. Okay? So here, when we plug in, see the integral of x squared is x cubed over 3, but if I'm going to evaluate that at infinity, I get infinity cubed over 3 minus 0 cubed over 3. So infinity minus 0 is infinity, so that diverges because I have an infinite answer. Okay? So it's when you get a specific number, converges, infinity diverges. All right. Okay, if there is a vertical asymptote at a point between the limits of integration. So let's say if we're integrating from like 0 to 5, and you have a vertical asymptote in the middle, then you have to split the integral at the vertical asymptote. Okay? Now, if you see by symmetry, if the vertical asymptote happens to cut it exactly in half, then maybe you only have to do one and then you could double your answer. But usually that doesn't happen. Okay? So let's look at this practice here. See, just looking at this, where would the vertical asymptote occur?
Would it be at 2?
At x equals 2, because that's what makes the denominator go to 0. Okay? So then you say, well, wait, the integral goes from 0 to 3. So 2 is right in there. So that means that there's a vertical asymptote inside our limits of integration. Okay? So that means it's going to be improper. So what we have to do then is say, all right, we're going to integrate from 0 to 2, the vertical asymptote, and then we're going to integrate from 2 to 3, basically. But see, we can't actually integrate to 2 at 2 because at 2, we would get a 0 in the denominator. Okay? So, let's see if... So it's kind of like this idea. If we here, so we're going to have this vertical asymptote in the middle of our limit. So the first one, we're just going to go from 2 to the left. So from 0 to 2 to the left. So from 0 to b, then take the limit as b approaches 2 to the left. And then on the other one, we're going to say from 2 to the right on to 3. So from the limit as a approaches 2 to the right to 3. Now, I understand how you might say, you know, it just seems like it would be easier if you didn't put these limits on here. But see, that's how you can do it. Without the limits, it's not a proper integral. Technically you can't integrate it. Okay? If the limit of integration gives you a 0 in the denominator, that's not going to work. Okay? But what would be so what's the integrand of this? Or what's the antiderivative of dx over x minus 2?
The natural log of x minus 2.
Very good. Okay? So then we do that. So we have the limit as b approaches 2 from the left of the natural log of the absolute value of x minus 2 from 0 to b. All right, and then this one, the limit as a approaches 2 from the right of the natural log of x minus 2 from a to 3. So they both are going to have the same antiderivative. So the calculus there is going to be the same. All right, so now we plug in the b and the 0. Oops. Okay. Let's see. I'm going to... whoops. Okay, so here, let's put in an extra step here. So this is going to be the limit as b approaches 2 from the left, and this is going to be the natural log of b minus 2 minus the natural log of 0 minus 2, an absolute value. Plus the limit as a approaches 2 from the right. So you plug in the 3. So you've got the natural log of the absolute value of 3 minus 2 minus the natural log of a minus 2. Okay? And so now as you plug in 2, see this is going to, 2 from the left, values that are near 2, well, when you subtract 2, it's going to be, this value is getting close to 0. Okay? So now, what helps is if we understand the graph of the natural log, as the x values get closer to 0, the y values get close to negative infinity. So that's where that comes from. And that's, okay, minus 0 minus 2 is negative 2. Absolute value of negative 2 is 2. Boom. All right, then the natural log of 1 is 0. And then the natural log of a minus 2, once again, as a is close to 2, this is going to be close to 0. And so as you take the natural log close to 0, you're going to get negative infinity. So negative infinity plus minus a constant plus 0 plus another negative infinity is negative infinity. And so then it diverges. Okay, so really quick, the last thing here is that what do you think will happen if we don't split the integral and just put it in our calculator? Well, what happens is you get an error message. The calculator can't handle it because you've got so if you just want to try that, I mean, we've got a minute to go here, but just pretend like you don't know anything about improper integrals. If you just put that in, you'll get an error message. And that's why. Okay. Oh, we lost. Okay, so did you get an error message, Weston?
My calculator is thinking right now, so.
It's thinking. So Tobias, what I want you to do is just put that in the calculator and see that you'll get an error message. And it's because we have this vertical asymptote in the middle, between our limits of integration.
Yeah,
anyway,
I got an error.
Okay, good. So that's it for chapter 8. So I'm going to post the 8.8 quiz as well as the 8.8 test. So, and if you have any questions, you can ask me tomorrow. So tomorrow will be your time with me, and then, like I said, then we'll have spring break, a sub, and then the midterm. But I will be available over email. It's just it might take a day or two for me to respond. Okay, so anyway, try that, Tobias, to make sure that you can see that that's going to give you an error, and we'll go from there. So, any other questions? We got about 5 seconds. All right, you guys. Well, thanks for working hard, and we'll see you tomorrow.